How many grams of nitrogen are in 75 grams of caffeine? I have no idea how to work this problem, but I know that the first thing I'm going to do is start off with the only number given to me. And that would be 75 grams of my caffeine. Now, the only thing I ever know how to do in chemistry with grams is to get rid of them. So I'm going to go to my periodic table and I'm going to calculate my molar mass of caffeine. So I'm running to the periodic table, calculating my molar mass of caffeine. Well, I've got 8 carbons, each at 12.011 grams. I've got 10 hydrogens, each at 1.008 grams. I've got 4 nitrogens, each at 14 point each at 14 point, come on. Sorry, my internet browser began working really slowly there. 14.0067. And then we can't forget our oxygen. I've got 2 oxygens at 15.9994. So let's punch those all into our calculator and we get 8 times 12.011 plus 10.08 plus 14.0067 times 4 plus 2 times 15.9994 equals, I got 194.1936 grams. And since that's important, let's do a quick double check. That's going to be roughly 90. That's going to be roughly 96 grams. That's going to be 10 grams, 28, 56, 32. That gives me 12, 4, 1, carry the 1. That gives me a 10, 6, 9, 194. So yeah, that's right. So 1 mole of caffeine is 194.19 grams. So now I've gone from grams of caffeine to moles of caffeine. Well, moles of caffeine is not what they're asking for. They're asking for grams of nitrogen. In order to go from one substance to another, I have to have a molar ratio. Most of the time that's given in a chemical formula, but not this time. It's going to be given to us not by a chemical reaction, but by the chemical formula itself. If we look at that chemical formula of caffeine, it tells us that we have 4 nitrogens for every caffeine molecule, right? See it right there? So we have 4 moles. How did I get switched to marker mode? 4 moles of nitrogen for every 1 mole of caffeine. So I place my moles of caffeine where they cancel out. I now have moles of nitrogen. I'm not wanting moles of nitrogen, so I'm still going to have to go to one more step. And that one's an easy and an old friend of ours. Whoops, forgot to change my crayons. 1 mole of nitrogen. Wow, I can't write the letter N today. Is 14.0067 grams. So now I have the unit I'm looking for, grams of nitrogen. Multiply everything on top, divide through by everything on the bottom, and I get 21.6 grams of nitrogen. I want to double check that. That seems awfully high as a percentage. Actually, no, it doesn't. That seems about right, but I'm going to run it through my calculator one more time. 75 divided by 194.19 times 4 times 14. Yep, that's it. All right, how many moles of sulfur and 36.9 grams of aluminum sulfide? We're only given one number in the problem, so we know that that's what we're going to start our line with. The only thing we ever know how to do with grams is to go to moles. So I'm going to place them where they cancel out. So I need to figure out the molar mass of aluminum sulfide. So I go to my periodic table. I have 2 moles of aluminum, each at a mass of 26.98, 5 grams, and 3 moles of sulfur at a mass of 32.065 grams. And that gives me 150.158 grams. So I know 1 mole of aluminum sulfide is 150.158 grams. So now I've gone from grams of aluminum sulfide to moles aluminum sulfide. Now I want to go to moles of sulfur. I need a chemical relationship. Most of the time that's given to us by a chemical reaction. In this case, it's actually going to come from a chemical formula that tells us for every 1 mole of aluminum sulfide I have 3 moles of sulfur, right? That's what my subscript there is telling me. So 3 moles of sulfur to every 1 mole of aluminum sulfide. That's what they're asking for, so I'm going to multiply everything on top, divide through by everything on the bottom. So that gives me 36.9 divided by 150.158 times 3, and that's going to give me 0.1737. I've got 3 sig figs there, so I'm going to have 3 sig figs in my answer. That's it. Beep.